Competition. It's a concern and a challenge for more organizations today than ever before. The fact is, you've got to provide customers with better products, higher quality products, faster than anyone else if you're going to survive in the global marketplace. Many successful organizations are taking steps to meet these challenges by changing their work processes. They're streamlining operations, improving quality, reducing costs, and doing a better and faster job of bringing products to market. Hi, I'm Russ Christoff, and I'll be your host for this program on the ways that Macintosh personal computers are helping manufacturers meet today's challenges. I'll show you how Macintosh can help build better bridges between the departments that design your products and those involved in manufacturing. We'll focus on 4 areas in which Macintosh offers you a significant advantage by facilitating collaboration between people, processes, and technology, by providing ease of integration in multi-vendor environments, linking desktop systems to everything from workstations and mainframes to printers and file servers, by giving you access to a wide range of powerful solutions for engineering and manufacturing, and by providing a clear pathway of growth and innovation, 2 hallmarks of Macintosh that can give you a decisive edge over the competition. Together, these 4 advantages have made Macintosh the best-selling personal computer in technical disciplines, according to market research from DataQuest. In this videotape, we'll show you how organizations throughout the country depend on Macintosh and its unique system software and applications to get the job done. Faster, easier, better. We'll take you to Hudson Products, a division of McDermott, which is a Fortune 500 company, where Macintosh facilitates total quality management throughout the company, greatly improving the quality and speed of production.
And in the last 3 years, our revenues have tripled. And we really haven't added people to our proposal department, and I attribute that to the Macintosh system.
We'll show you the shop floor at Allied Signal's Garrett Auxiliary Power Division, where Macintosh provides almost instantaneous communication between manufacturing and engineering, shortening the creation of manufacturing instructions by as much as a year.
We can take pictures with the camera, annotate those right on the Mac, and within a couple weeks they would have documentation for the plumbing and electrical that previously we would have been building 6 to 9 months just by photos, which is a great solution for us.
And we'll visit the electronic pager division of Motorola Corporation, where Macintosh provides the flexibility to respond to design changes quickly and match production to demand.
The old way that we used to employ, which was batching piece parts or sub-assemblies, the cycle times may be as long as 30 days to produce 1 pager. Today's cycle time for manufacturing of a pager, a display kind of pager, is less than 2 hours in this building. So it has in fact increased our productivity many times over.
Manufacturers are turning to Macintosh to solve very specific problems of communication throughout the company, between departments, between work groups, between individuals. Because when you improve communication, the results ripple through the entire organization, substantially improving product quality, speed of production, and cost effectiveness. These principles are the driving force behind many of today's best-known manufacturing strategies. You've heard the names: total quality management, simultaneous engineering, design for manufacturing. All these strategies have something in common: better and faster collaboration. Macintosh is the only computer designed from the ground up to facilitate collaboration. It's built right into the system software. For example, Macintosh allows people using very different applications to share information and ideas. Because of the consistent interface between applications, it's easy to copy images and text from one application to another. Cutting and pasting text, tables, and graphs allows your people to work together, quickly creating documents in hours instead of days or weeks. Our system software, called System 7, extends this simplicity to sharing information over networks. Any Macintosh user can designate a folder or hard disk on their system to be shared with others. As soon as they select the users who will have access to these files, the others can connect and use the files instantly. No file server is required. And System 7 can make communication instantaneous, with instant updating of information through a feature called Publish and Subscribe. Publish and Subscribe gives you the ability to continuously update information right over the network. Suppose, for example, that engineering needs to be able to change a product's specifications from time to time. But Technical Publications is working at the same time on a document that includes those specs. Engineering simply publishes their work, and TechPubs subscribes to it. Whenever engineering makes a change, the TechPub document automatically updates as well. And Publish and Subscribe works across the network, with no need for additional file transfers or cutting and pasting. These are just a few of the built-in features for collaboration that make the Macintosh an ideal tool to help people work together. At Hudson Products Corporation, top management has put these features to work to increase productivity.
I think it's tougher today to stay in business, being an American manufacturing industry. We have to stay on top of our business so that we can compete in the global market.
Total quality is what it says it is. It's changing the way you do business. It's valuing and empowering every employee.
One of the systems that we've developed and are implementing is our proposal process system. To get our proposals out, we have teams, and these teams include engineers, salesmen, clerical, draftsmen, and the Mac is the tool that integrates all these guys together. The engineer uses the HyperCard stack to access the engineering algorithms to size the unit. The salesman uses the Mac to build the letter, the proposal letter. Some clerical staff are actually making the proposal drawings using MacDraw 2. But all of these guys use the HyperCard interface in our common proposal system to pull the package together.
You can't manage all the aspects of a business without an integrated information system. You couldn't do it. There's too much data and too many people have to access it. What you find is that all of your processes are integrated into the overall process that is your business. And to do that, you have to have a system to manage it with. Ours is Macintosh, and it works.
At Hudson Products, Macintosh helps to integrate people and information throughout the organization. It can do this in part because Macintosh seamlessly bridges the gap between desktop systems, mainframes, mini-computers, and workstations. For starters, Macintosh has its own built-in networking system called AppleTalk, which allows you to add other Macintosh computers to the network just by plugging them in. AppleTalk isn't an add-on product. It's built right into the computer, and it's supported by all the most popular local area networks, including Novell NetWare and Banyan Vines. So Macintosh computers can join your network with minimal additional support from systems administrators. Macintosh also supports other industry standards such as Ethernet, Token Ring, TCP/IP, and NFS. But Macintosh does much more. It adds value to your multi-vendor environment. It can revitalize your current systems because it not only integrates easily with a wide range of platforms, but it can make it easier for people to access and use network data and applications. For example, let's take a simple data exchange between Macintosh and an IBM PC. You can easily exchange data with any MS-DOS-based computer simply by slipping a DOS disk into a Macintosh disk drive. Every Macintosh can read and write to DOS-formatted disks. Many Macintosh applications can open and use your existing DOS files. Macintosh personal computers can access the most important host environments, including IBM, Digital, and Tandem. Many Macintosh applications can directly query SQL databases on your host systems using Apple's data access language, a part of the Macintosh operating system. They range from Macintosh productivity tools such as spreadsheets and databases to data access tools specifically for building SQL queries, managing host connections, and formatting reports. Of course, one of the most important facets of integration is compatibility with Unix, one of the mainstays of the engineering world. Apple's Unix is called AUX, compliant with System 5 2.2 and meeting standards such as POSIX. But AUX is much more. It brings the full benefits of the Macintosh operating system to a Unix platform. AUX provides the familiar Macintosh desktop environment with its intuitive user interface, cut and paste features, and the capability to run Macintosh, X Windows, Motif, and Unix applications all at the same time. So AUX is compatible with hundreds of your existing Unix applications. Its impressive connectivity in multi-vendor environments, its built-in graphical user interface, and its ability to integrate information from many sources combine to make Macintosh a valuable tool in enterprise-wide systems. Let's see firsthand how Macintosh can bring together information and ideas. Suppose a project leader needs to create a single document that will draw information from many different departments. He'll be working with a number of Macintosh applications, including Lotus 123 for the Macintosh, an ideal tool for combining and presenting data from a number of sources. For this demonstration, we're connected to an IBM mainframe. In this window, the Macintosh is emulating a 3270 terminal session. We're also connected to a digital VAX. And we've connected to a Unigraphics workstation via X Windows, running under the Macintosh operating system, to access a wireframe product illustration. The Macintosh copy and paste feature allows you to use different applications, even different computer systems, to create the elements for reports, technical publications, and the like, and produce the final document with Macintosh applications. First, we'll copy the CAD drawing and paste it into our report. We're creating the report with FrameMaker, a powerful technical publishing application for processing large structured documents. FrameMaker combines word processing with the ability to integrate graphics and tables from other sources. To get a sales history of the product, we access a sales department database on the IBM host. Apple's SNA Products and Services, or SNAPS, gateway allows the Macintosh to easily connect to SNA and take advantage of all SNA services. The terminal emulation window looks and works just like a 3270 terminal screen. But with Macintosh, we can select the data we need and then paste it into another document, in this case our Lotus 123 spreadsheet, for further manipulation. This spreadsheet was created with Lotus 123 for the Macintosh, but we could have used a file made with the DOS version of Lotus 123 and open it with the same application. Lotus 123 for the Macintosh can also run all of your DOS version macros, and it has graphics and formatting features that the DOS version doesn't offer. To complete our sales table, we need data from another platform, this time a VAX mini computer. We'll move to the VAX window, call up our report, and there it is. Once again, we copy the data we need by selecting it, choosing Copy Table from a Macintosh menu, and then we paste it into our spreadsheet. Lotus 123 combines the figures from the IBM and VAX reports and calculates our totals. We'll copy the table and paste it into our report. Finally, we'll convert the Lotus 123 data into a FrameMaker table, which gives us formatting capabilities that help to communicate information clearly and consistently. Macintosh document processing applications like FrameMaker go far beyond simple text editing to allow you complete control over your document's format and style. The Macintosh can help you gather, analyze, visualize, and communicate information and ideas in ways that other personal computers and even workstations simply can't match. Here's Brad Lang, Data Communications Specialist at Motorola's ASIC division.
We are pulling information from different Unix platforms, Suns, Mentors, and Apollos. The information can be ASCII files, it can be graphics. In a couple of instances, we've pulled information from some IBM computers and converted it over. All this information we combine together onto essentially one station. It's all done on the Macintosh. If I ever want to exchange data between any platforms, I found that the Macintosh is the most stable platform. It's my main platform that I'll do it from. It's the best there is that I've used so far.
Now, let's see some of the kinds of applications that are available for Macintosh. Of course, Macintosh is famous for its productivity applications, from word processing to spreadsheets to project management. But there's a wealth of engineering and manufacturing applications available for Macintosh as well. They offer a clear advantage over many applications designed for other platforms. Advantages such as a consistent interface that makes learning and using software much easier than on other platforms and considerably reduces training time. Let's take a look at some of these superior tools for data access, visualization, and communication. Macintosh offers a wide range of engineering tools for everything from 2D conceptual design to 3D conceptual design, like this advanced freeform design tool from Alias Research called Sketch, to more detailed 3D computer-aided design and working drawings, and advanced design for manufacturing applications. This one, Assembly View, is an analysis tool that lets you calculate assembly time and manufacturing costs for process planning. And there are specialized tools for visualizing complex ideas and information. And on the shop floor, Macintosh offers some of the newest and most innovative tools to link together machines and people, in manufacturing resource planning, in management and data collection, quality control and plant management, desktop CAM systems for prototyping, and distributed control systems such as these robotic cell controllers. This is just a sampling of the specialized engineering and manufacturing applications that are available today for Macintosh. One reason Macintosh is a preferred platform in technical disciplines is its superior ability to help you visualize and synthesize information. Macintosh leads the personal computer industry in graphics and multimedia, and the recent release of Apple's QuickTime, an extension to Macintosh system software, expands that lead. Using QuickTime, a digitized movie can be pasted into any QuickTime-aware document, like this one created in MacWrite 2, making it easy to incorporate dynamic material into business documents, training materials, and so on. Here at the Garrett Auxiliary Power Division of Allied Signal Corporation, QuickTime and Apple's HyperCard combine to accelerate and improve communications between engineering and manufacturing. As one of the country's biggest manufacturers of gas turbine engines, Allied Signal Corporation has to stay on top of the competition. That's why, when they needed a better way to send build instructions to the shop floor, they turned to Macintosh.
The clearer we can display the information to the mechanic, the quicker he can build the engine, the less mistakes we make, and this improves our whole manufacturing cycle, and it lets us put a better product out to the customer, which is the ultimate goal.
What we've done here at Allied Signal is replace an existing paper-based system that utilized hand-drawn or computer-aided drawings, wireframe drawings, with a network of Macintosh quadras displaying a simple, easy to understand, clear format of images, online text, bill of material information, calculations. The list really goes on as far as the information that we've put at the fingertips of the mechanic. Then we'll go down with the mechanic with the outline, and we will videotape certain steps along the way on that assembly procedure. We'll bring that videotape up, import those images into a canvas file, place them in the HyperCard stack, import the bill of material information through the 3270 emulation card onto the draw sheet within the HyperCard application, thereby reducing that 6 month to a year and a half lead time for the mechanic to get his documentation down to 2 or 3 weeks. So we've taken a average of a year out of the cycle.
We're expecting the cross-training procedure to take about 1/4 of the time with the Mac than it did in the past.
Before choosing Macintosh, Garrett considered a number of other systems, including mainframe systems that would have been far more expensive.
The cost on the Mac was about 1/4 of the other two solutions, and the quality was better.
The costs involved in the mainframe solution, if they would have given us the hardware, the price of the software and maintenance would have surpassed what we're going to spend on an Apple solution, lock, stock, and barrel.
Apple showed us that they had a technology that could be incorporated as a software solution. The Apple solution, the Macintosh, is the best that's available. They're the leaders in the areas that we are looking at that we couldn't find anywhere else.
At Allied Signal, we saw how engineering can visually communicate with manufacturing using QuickTime video technology. Now let's see another example of a manufacturing shop floor solution, this time at the Motorola Corporation. In Motorola's pager division, they're using Macintosh to gain an advantage in the highly competitive field of display pagers. At Motorola, Macintosh computers and vision software from Automatics control assembly line robots that precisely place components.
The marketplace demands the fact that you have to have flexibility in the manufacturing process. And we cannot afford to have factories that do one thing, hard tool, one type of radio. So what we have done is we opted for the philosophy that each line must be flexible to do many different form factors and many different styles of radios. Using the Mac tool or the Macintosh has in fact allowed us pretty much to go from the office here all the way out to the design lab, and from the design lab all the way out to the robotics controllers, sending files across from a manager to an engineering group to a production group. It is in fact a tool that is very easy to use.
We knew that we had to drive our manufacturing costs down, and we had to provide the best product at the lowest cost in order to compete. And that was a corporate mandate and just common sense. The Mac is part of the quality evolution that happened here. It's one of the tools that actually gave us a handle on what's going on and able to put our problems and our processes in perspective. And it basically, changed the way we did business. The Macintosh is actually an automation cell controller. It controls all the aspects of each individual robotic cell, the vision, the I/O for the cell, and it controls where the robot begins and ends its routines.
The old way that we used to employ, which was batching piece parts or sub-assemblies, the cycle times may be as long as 30 days to produce one pager. Today's cycle time for a manufacturing of a pager, a display kind of pager, is less than 2 hours in this building. So it has in fact increased our productivity many times over.
Both Allied Signal and Motorola have increased productivity in their manufacturing operations because Macintosh gives them the flexibility to adjust to changes. Another advantage of the Macintosh is what we call growth without disruption. Each new advance in Macintosh technology, for example the new System 7 operating system, is clearly designed to include previous models of Macintosh computers. So you can use new state-of-the-art software with almost any Macintosh, and at the same time preserve your investment in software and data. This growth without disruption will continue with the new products being developed as a result of the Apple-IBM alliance. Right now, products are being developed and released that tightly integrate Macintosh and IBM systems. For example, Apple has licensed IBM's 16-megabit token ring technology. IBM, in turn, has licensed AppleTalk, Apple's networking system, for OS/2. Another development to come out of the IBM alliance will be the new RISC-based PowerPC architecture, created as a joint effort between Apple, IBM, and Motorola. PowerPC Macintosh computers will combine the ease of use and intuitive interface of the Macintosh with the power of RISC technology. Apple will help to preserve customers' investments in Macintosh applications and data by ensuring that today's Macintosh applications run on future PowerPC Macintoshes. Hudson Products, Allied Signal, Motorola, and thousands of other manufacturing organizations have seen a significant improvement in productivity and cost savings, thanks to Macintosh. It can't be traced to a single application, or a single networking capability, or a single advantage of the Macintosh interface or system software. Rather, it's the sum of all these things that are the Macintosh advantage. We hope you've seen what Macintosh brings to development, design, and manufacturing processes. Better collaboration, utilizing built-in features that let people share ideas and information easily. Superior integration of people, processes, and technology. Innovative solutions, and better ways to get the job done with your existing resources. And growth and investment security. The confidence that Macintosh you buy today will fit into the new technologies of tomorrow. Macintosh delivers all of this, the power that allows you and all of your people to attain their very best.
Well, obviously, in the management of all that data that a process like this generates, you need a good way to handle it, a good way to utilize it, to access it for analysis, to exchange it. And the best tool that I have come across in a long, long time is this thing sitting back over here, and that's my Mac.
The total quality management process has been a critical factor of Hudson's success. We're constantly attempting to improve the processes and the methods we use to achieve our work, and the TQM is the heart of this. And the Macintosh is a tool that we use to implement the TQM process.